Salam and welcome. So today we're going to be working on the question on the screen that says a chemical reaction takes place in a container fitted with a piston of cross-sectional area 75.0 centimeter cube. So we have the area to be 75.0 centimeter squared. Sorry, not centimeter cube, centimeter squared. As a result of this reaction, the piston is pushed out through 25.0 centimeter against external pressure of 150 kilopascal. So we have a distance traveled by the piston as a result of the reaction to be 25.0 centimeter. And this happens against an external pressure. So P external, which is 150 kilopascal. And we're asked to find the work done by the system. Now, the first thing you have to do in a question like this is for you to basically draw so that you can see like the reality of what you're working with. So the first thing you do is you're going to draw the piston before the reaction. Sorry, you're going to draw the co- um container before and after the reaction and everything that is going on in it. So the piston is what I'm drawing right now. You see that the piston is this, and we're told that it is 75.0 centimeter squared. So area is 75.0 centimeter squared, and we have the distance traveled by the piston, and that is going to be 25 centimeter. So that's the distance. Now, if we look at our work from here up until here, this is the distance traveled. So this whole thing here is 25 centimeter. So that's how much is traveled when work is doing the distance. So from the beginning, before work started on the system and after work started. So it is a 25 centimeter distance that piston traveled as a result of the work done by the system. Now, the external pressure that was being applied is 150 kilopascal. So that's what the pressure is. So that's basically it's 150 kilopascal. So we're being asked now the work done by the system. So when we go back to the fundamental explanation or definition for work, we know work is force times distance. That is basically what work is. But because it's a situation where work is being done by the system, the work is going to have a negative value because the system is doing work. Hence, the negative value shows that work is being lost. Sorry, energy is being lost by the system because the system is doing work. So we're going to denote it as a negative. And then we have force times distance. Now you can see that from our information, we're never given the value for force. We're only given the value for area and the value of distance. But when we think of our fundamental understanding of chemistry, we know that pressure that we're given is the same thing as force divided by area. Hence, when we solve this equation in a box in terms of force, we end up with force equals pressure times area. Now we have what we need. So we're going to input it in the equation here. Work, which is negative force times distance, is now going to be negative pressure times area times distance equals basically work. So this is it right here. So that would be work equals negative pressure, blah, 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 blah. Sorry. Yeah, negative pressure times area times distance. But one thing you have to know is that I'm going to be rewriting this negative pressure times area times distance. I'm putting area and distance in the bracket just because they have similar units, and you're going to see the reason why I'm doing it in a second. So we have the value for area to be 75. We have the value for the distance to be 25. So area, just looking at this one here, area times distance, 75 centimeter squared times 25 centimeter would give you 1,875 centimeter cubed. This is basically the answer to the question. So, yeah, work now is going to be negative pressure, external pressure times AD. So that would be times AD. Now, the normal thing we're supposed to do, it would have been for us to basically just multiply everything. But we have to remember that pressure, right? Oh gosh, what's going on with this pen? So now the normal thing we're supposed to do would just be to just input the information in the equation here. But this cannot happen because even though we have the value for pressure and then area and then distance, the issue we have with this question is that we know that pressure is force over area. Okay, so hence the unit is Newton per meter squared. In this case, we have kilopascal. Um, that's just basically times 10 to the power 3 Pascal. Well, the unit for Pascal is also Newton per meter squared. But then we have the volume in terms of centimeter cubed. Hence, we cannot put centimeter and meter in the same calculation because we need the units to be similar in value, um, and basically the degree that is on top of the unit, we need it to be similar in order for us to do any further calculation. So what I'm trying to tell you is that we have to convert centimeter cubed right here to meter cubed. That's just it. We just need to do unit conversion. So we know generally, because we learned it in elementary school, we know that 100 centimeter equals 1 meter. Hence, 100 centimeter all cubed is going to give us 1 meter all cubed. So doing the math would just mean 100 times 100 times 100. That's going to be 1 million centimeter cubed equals 1 meter cubed. So that is it. So we're going to use this information that we have to solve. We're going to use this information that we have to solve and get the value of 1875 centimeter cube in meter cubed. That's just basically what I'm trying to say. So we're going to say 18. Let me separate. We're going to say 1875 centimeter cubed times, using dimensional analysis, 1 meter cubed would be up top because we're trying to solve the question in in meter cubed. And then you have the 1 million centimeter cubed. So we cancel out centimeter cubed, cancel centimeter cubed. 1875 is the same thing as us getting 1.875 times 10 raised to the power of negative 3 meter cubed. And this is what we're going to insert in our question. So now we have this 1875 centimeter cubed in meter cubed. Now we have the pressure. What is the pressure again? The pressure is 150 kilopascal. Well, remember now that 150 kilopascal to Pascal is the same thing as saying 150 times 10 to the power 3 Pascal, or 150 times 10 to the power 3 Newton per meter squared, because Pascal is the same thing as Newton per meter squared. And we're just going to input all of that information in our equation on the left. So let me use a different marker. So W equals negative, the P external is 150 times 10 raised to the power 3 Newton per meter squared times the value for volume. So that would be 1.875 times 10 raised to the power negative 3 meter cubed. So cancel our meter squared, remove cubed from meter. So work done equals negative 150 times 10 raised to the power 3 times 1.875 times 10 raised to the power negative 3. So just cancel out this side and this side, basically the negative 3 and the positive 3. So when you do the calculation in your calculator, you end up with 281.25 Newton meter. And since, of course, this question that we're given is in 3 sig figs, we can stop writing the value on that one. So that's going to just be W work done equals negative 281 Newton meter, or work done equals negative 281 joules. Don't forget, Newton meter is the same thing as joules. Just like pascals is the same thing as Newton per meter squared. And this is basically how you answer a question like this. If you have any questions, please put it in the comment section. If you would like to succeed and get an A in all your STEM related courses, make sure you email me at shohabitutoring@gmail.com in order for you to book an online tutoring session. I help students in middle school, high school, and college to succeed in all their STEM related courses. And I also do private and group tutoring. So make sure you email me if you want to book a session or if you have any questions about the services that I render. I wish you guys all the very best. Make sure you keep working hard. And Assalamu alaikum wa rahmatullahi wa barakatuh.